A 5-digit digital counter displays a number. When Christopher looks at the counter upside down, he sees a different 5-digit digital number, which is 78,633 larger than the original number. What is the original number? Okay. Well, first of all, let's take a look at these digits that the that make up this digital counter. Okay. So I'm going to assume that there are 7-segment digital digits that look like this. There's 5, 6, 7, and 8. So let's look at all of the numbers and then figure out what they look like upside down. Because you can see actually from this that, for example, when you turn the 7 upside down, it's going to look like an L, which is not a digit. So not all of these digital digits look like digits when they're turned upside down. So let's see what they do look like when they're turned upside down. So the 0 is just going to look like a 0. Okay, so that's good. 0 works. A 1 is, when you turn it upside down, just looks like a 1. A 2 looks like this in the digital format, and when you turn it upside down, you can imagine that, this corner down here, this lower right hand corner, when you rotate it up, it's going to become the upper left hand corner. And so you can see when we turn it upside down, it's still going to look like a 2. So I imagine, you have probably a paper at home, and you could do this just by actually writing them out and turning the paper over. So, but that's kind of hard to do in this video. So next, let's look at the 3, and when we turn it upside down, it's going to look like a capital E. So when we turn the digit 3 upside down, it doesn't look like a digit anymore. So that means that our original number, and the upside down number for that matter, can't have a 3 in it. So let's look at the next number, 4. 4 is another one. When you turn it upside down, it looks sort of like a lowercase h. And that doesn't look like a digit, so we can't have a 4 in either of our numbers. A 5 looks like that, and when we turn it upside down, it's sort of like the 2. This lower right-hand corner becomes the upper left-hand corner, and so if we turn it upside down, it still looks like a 5. Alright, so let's look at the 6. So 6 looks like this, and when we turn it upside down, it looks like a 9. And we already talked about the 7. When we turn a 7 upside down, it looks like an L. So we'll eliminate that one. That one can't be in our number. An 8, for an 8, we have all 7 segments lit up. And when we turn it upside down, we still have all 7 segments lit up. So it still looks like an 8. And then a 9, turn that upside down, and it looks like a 6. Alright, so that's all our digits. So you can see we've sort of eliminated, some of the digits that can't be in our number. So, alright, let's take a look at it. Let A and B and C and D and E be the digits of this 5-digit number. And we're told that when we add 78,633 to the number, we get the number upside down. Okay, now, again, I can't turn my computer upside down, so I'm going to try and write these numbers upside down. So there's an A upside down. Here's a B upside down, a C, and a D, and the E upside down. Alright, so when our first digit of the original number has to look like the last digit of the upside down number, only turned upside down, right? And so on. The last digit of the original number becomes the first digit, of the upside down number, only the digit is upside down. So I am actually going to start here on the left-hand side of the equation. And I want to start there because 7 is a pretty big number, and we know that when we add a to it, the answer has to be a digit. We can't have an overflow. You know, we can't have a 10 or 11 or a 12 because then we'd have a 6-digit number. All right. So E has to be a digit, so that limits the possibilities for A. A can only be 0 or 1 or 2. So let's take a look at those possibilities. So let's start with 0. Let's say that A is 0. Now this says it's a 5-digit counter, and it displays a number, but it doesn't say that it's a 5-digit number. A lot of times when you see 5-digit numbers, that means the first digit can't be 0, because otherwise it would be a 4-digit number. But I'm not going to rule that out at this point because we have 5 digits in our counter, but maybe the first digit is a 0. Maybe it's a possibility. So let's take a look at that. I'm going to leave E for now. 7, 8, 6, 3, 3. Okay, so we're going to add this. All right. The other thing we don't know is that when we add B and 8, it's very possible that we could have a carry, right? We could have a carry that looks like that would add to it. So the possibility here is when we add 0 and 7 is that we get 7 or 8. Okay? And 7, it can't be a 7 because that doesn't look right upside down. When we turn it upside down, that would mean E has to be an L, but that's not a digit. So we can eliminate that, which means that if A is a 0, then there has to be a carry, and then E, the upside down E, is an 8, which would mean that this is an 8. And then we'd add that together, we get 1, and we'd have a carry. Okay, but we have a problem, right? Because this A was 0, and A upside down does not look like 1. 0 upside down does not look like 1. Okay? So this case doesn't work. Alright? So A is not 0. Alright. So let's go on. Let's look at the case where A is 1. So 1, B, C, D, and I'll leave E. 7, 8, 6, 3, 3. Alright, we're going to add those. Alright, so again, we don't know whether there's a carry or not. If there's no carry, it's an 8, right? And if there is a carry, it would be a 9. Okay? Alright, so if there's no carry, then this is an 8. And if there is a carry, then this last digit here would be a 6. Okay? Alright, so if I add 8 and 3, that gives me 11. So I put down a 1 and carry a 1. If I add 6 and 3, that gives me a 9. But 9, I could write that down here, 9 would not match up because 1 upside down does not look like a 9. So this is not the case. So this can't be a 6, and this can't be a 9. Okay? But the other case works out. 1 plus 7 is an 8, so that means that E is 8, and then we get 11 and carry a 1, so the 1 looks like the 1, so hey, we're good. So 1 is a possibility. I'll circle that one. Alright, so let's look at 2. What if this is a 2? 7, 8, 6, 3, 3. Okay, we have B, C, D, E. Now, here we cannot have a carry, because if we had a carry from this addition as B plus 8, then this would be 10, and then we'd have a 6-digit number, not a 5-digit number. So the only possibility here is that this is a 9, which would make this a 6, and then this would be 6 plus 3 is 9. right? But a 2 upside down does not look like a 9, so this, again, we can eliminate too. All right, so we have A and E. We're making progress. Let's keep going. The next thing I want to look at, I see that B and 8, in this case, cannot have a carry, right? Because the 9 didn't work out. So that really limits what we can have for B as well. So B could be 0 or it could be 1. So let's go through the same process here. We know that A is 1. Let's assume that B is 0. Okay, so let's make that a 0, and then we have C and D. I want to leave blank because and then we know that this is 8, right? So we have this D. I'm going to leave it open for now. 7, 8, 6, 3, 3. We add those together. We get 8. 1, carry the 1. All right. Now, again, we don't know, is there a carry or not? Now, in this case, we could have a carry, and it would still work. We just can't have a carry to come over to this 10,000ths place here. All right. So this is either, if there's no carry, it's an 8. Okay, this was an 8 too. If there is a carry, then it's a 9. Okay. And if this is an 8, then this is an 8, right? If this is a 9, then this is a 6. And this becomes, okay, if it's an 8, then it's a 1. And if it's, oh wait, sorry, no, wait a minute, we can't forget the carry that we had from our 8 plus 3, right? So, if this is if this is an 8, that's D, right? If D is an 8, we have the 3, and then we have the carry, so this would be a 2. If this was a 6, we'd have 6 plus 1 plus 3 is 10, and then we'd have another carry, right? So you can see here, this is the B, and this is the upside down B, okay? So 2 upside down does not look like a 0, okay, because we were working through the case where B is 0. So that cannot be the case, and that cannot be the case, and that cannot be the case. Now here, the 0 looks like the 0 upside down, and 9 looks like the 6, so everything's working out there. Alright, so let's look at the case where B is 1. Alright, so we'd have 1, 1, C. I'm going to leave this blank, and then I'll put the 8. Alright, because that's what we know so far. 7, 8, 6, 3, 3. Add that up. This is a 1, carry the 1. This we know is an 8. Now, in this case, we can't have a carry for this to work out, because we said that we don't have a carry to this column here. Otherwise, that doesn't work out. So we have no carry in this scenario up here where it worked out. So we had 1 plus 7 is 8 with no carry over to that next column. So here, if we had a carry, we'd have a coming over from this C plus 6 column. If we had a carry, then we'd have an overflow onto the next column, and we don't want that, okay? So our only scenario that works is this would be a 9, and then this would be a 6. And then this would be a 9, right? Because 6 plus 3 is 9. But we have a problem here because 1 upside down does not look like 9. Okay, so that one doesn't work. Alright, so this is the case that works. So far, what we have is that A is 1 and B is 0. Okay? So, alright, let's write that up. Let's write that out. 1, 0, C. make that